Welcome to lesson 1.6, Solving Equations. Solving equations with only one operation involves using the inverse operation to undo the indicated operation found in the equation. Addition and subtraction are inverse operations. Multiplication and division are also inverse operations. So what I'd like for you to think of is a scale. The scale that I want you to think of is one that looks like this, where if you have the same weight on both sides, then the lever across the top, this little gizmo at the top, is going to be flat because everything will be balanced. If you have something that weighs more on one side than the other, then you're going to have a slant here. It's not going to be equal. It's going to be imbalanced. And an equation has an equal sign. So that implies, and it actually comes from this line in the scale, that implies that both sides of the equation are balanced. And the trick of solving an equation is to keep them that way. So the rule to solving an equation is whatever you do to one side, you must do to the other side. So let's walk through example problem 1 to illustrate that. So here we have example 1. We've got 4 problems, and they're all different types of problems. We have addition, subtraction, multiplication, and division. So we're going to use the inverse operation to undo or solve an equation. And the golden rule of equations is whatever you do to one side, must be done, and that's must in capital letters and an underline, be done to the other side. Okay, so those are notes that you need to have in your notebook. So to simplify these, we're going to do the inverse operation to both sides of the equation. So here we're adding 9 to x. So the opposite of adding 9 is subtracting 9. And if we do it to this side, we're going to do it to this side as well. So this is going to be 0, so that's going to cancel. So if we draw a line here, all we have remaining is x on this side, and on this side of the equation, we have 19 minus 9 is 10. So x is equal to 10. Now the way you check your work is to substitute this value back into the original problem. The original problem was x plus 9 equals 19. So if I take the value of x and put it in, 10 plus 9, we know that 10 plus 9 does equal 19. So that means that we solved the equation correctly. So you can see how that works. Whatever you do to get, we want to get x by itself. We want to be able to say that x equals something. That's what we're solving for. So we want to solve to get x by itself. So we look at the problem and see, what do I need to do to get x by itself? And in the second problem, to get x by itself, we need to add 5 to make this cancel out, to make this 0. So then it would be x plus 0, which would be x by itself anyway, right? So if I add 5 to this side, I need to add 5 to this side. That would make this 0. So x would be by itself over here, and 12 plus 5 would be 17. So to check that, 17 minus 5, is that 12? It is. So that tells me that this is correct. So now let's look at the third problem. We know that when we have a constant and a variable, they're actually being multiplied. So instead of multiplying, we're going to do the inverse operation, and the inverse of multiplication is division. So I'm going to divide this by 3. But if I do it to this side, I have to do it to this side to keep the equation balanced. So when I divide 3 by 3, I get 1. So 1x, which we write by itself, we don't write the 1, we just write the x. It's understood that x is just got a 1 here. But mathematicians are lazy, so if they can get away with not writing a number, they don't. Bring down our equal sign, and 15 divided by 3 is 5. Now to check that, I'm going to substitute the value of x into the original problem. 3 times 5, does that equal 15? It does. So x is equal to 5. So now we have a division problem. So instead of dividing, what I'm going to do is multiply. So I am going to multiply both sides by 5 in order to solve. Now when I say 5 times x over 5, it's understood that because this is a fraction, that this turns into a fraction by putting it over 1, which means that the denominators are going to multiply. So 5x, and then the numerators multiply, and then the denominators multiply. The 5x over 5 is equal to 35, because 7 times 5 is 35. Well, 5 divided by 5 is 1, so that's 1x, so x is equal to 35. Is that correct? Well, let's see. Sub in 35 for the x divided by 5 is equal to 7. 35 divided by 5 is 7, so we know that this is correct. So you can see how if we do these two things, 1, the inverse operation to undo or solve, and 2, whatever you do to one side, do to the other, you will find the solution to your equation that satisfies the unknown information and makes the equation true. That is always the point of solving an equation, is to find out what makes the equation true. Let's look at example 2. Example 2 says to solve 2x plus 7 equals 15. So this is a little bit more complicated than the ones we did in example 1. It looks like there's going to be more than one operation. So the first thing I want to do is get the x term by itself. So to do that, I have 2x plus 7 equals 15. Let's get rid of the 7. So I'm going to subtract the 7 from both sides. So this cancels. That leaves 2x by itself, and that is going to be 15 minus 7 will be 8. Now I have a multiplication going on, so I'm going to do the inverse operation and divide on this side and on this side. So 2 over 2 is 1, 1x is written like that, 8 divided by 2 is 4. So now I need to check and make sure that that is the correct solution. So 2, substitute in for x the value that we found, which is 4, plus 7 equals 15. 2 times 4 is 8. 8 plus 7 does indeed equal 15, so the value of 4 for x is correct. So in example 3, I've got solve 2/3 times x is equal to 8. So I have a fraction with a variable. So I recognize the fact that this fraction is both dividing and multiplying x all at the same time. What's literally happening here is that I have 2 over 3 times x over 1. That's what's going on, and that equals 8. So the way that we can both do the inverse operation for division and multiplication at the same time is to multiply by the reciprocal fraction. So that means I am going to say 3 over 2 times this, and I'm going to do this to the other side as well. I'm just going to put 8 over 1 and turn that into a whole number and multiply times 3 over 2. So what happens is I get 6 over 6, right? So it'll be 6x over 6 is equal to, this isn't equal, 24 over 2. So you see that 3 times 2 times x, that's 6x, and 2 times 3 times 1, that's 6. So 6x, 6 divided by 6 is 1. So I get 1x here. And then I get 24 divided by 2, which is 12 here. So now I just need to check and make sure that that works. So I'm just going to come over here and I'm going to say 2 over 3 times 12 equals 8. And if you remember that this is a whole number, this is always going to be multiplied times the numerator. And the way to visually check that is just to put it over 1, right? That is what you're doing when you have a fraction times a whole number. So 2 times 12, that would be 24. 3 times 1, that would be 3. 24 divided by 3 is 8. So we know that x equal to 12 is the correct solution. So let's look at our next example problem. So here we have another problem with a lot going on. We have x over 3 minus 9 equals 6. So the first thing I'm going to do is do the inverse of this subtraction, and I'm going to add 9 to both sides. And draw my line, negative 9, positive 9. The opposites always cancel each other out and equal 0. So they go away basically. So what you would end up with is x over 3 plus 0, which matters to nothing, so we just leave it alone. So now I just have x over 3 is equal to 6 plus 9, which is 15. So now I have a variable divided by 3. How do I get rid of that? How do I kick that out so that I can multiply by my reciprocal? Well, remember that there's always that number 1 in front of your variable. 1 times x, and x is a whole number, is actually x over 1. So what's going on in this part is 1 over 3 times x over 1. That's what this is. So we can separate the x from the fraction by breaking it down into the operation that's happening. And that is equal to 15. We're going to go ahead and put that into fraction form too, because that's coming up. So now to get rid of this fraction times this, we're going to multiply by 3 and divide by 1. So that's just the reciprocal fraction. So then that gives me 3 times 1 times x is 3x. 1 times 3 times 1 is 3. And that's still equal to, oh wait, I forgot to multiply over here, so I have to do 3 over 1 over here. So 15 times 3 is 45, and 1 times 1 is 1. Well, 3 over 3 is 1. We write 1x just like that by itself. And then 45 over 1, that's just a whole number. Anything over 1 with a denominator of 1 is just the numerator. It's just a whole number. So x is equal to 45. So I'm going to check that by putting it back into my original problem. 45 over 3 minus 9 equals 6, right? We substituted the 45 where the x was. 45 divided by 3 is 15. 15 minus 9 is equal to 6. So that tells me that the value of 45 for x is correct. And that's how you would solve those types of problems by using the inverse operation. So let's do some more that are just a little bit more complicated and time consuming. Or not time consuming, but more detailed, I should say. So example 5 has a little bit more complicated situation. We have to do a couple of different things. The first thing we have to do is combine like terms because we have multiple terms here and some of them look alike. So let's do that first. Let's rewrite it. 2, and then I have a positive 6, a negative 3x, and then positive 5x. So now that they're grouped together, it's easier to combine like terms. 2 plus 6, that's 8. And a negative 3 and a positive 5. 5 is the larger number. So 5 minus 3 is 2. And because the larger number is positive, there's going to be a positive 2x is equal to 18. So now we have a positive value, which is the same thing as saying 2x plus 8. So we're going to take the opposite here and get rid of it on both sides. So negative 8, negative 8. That's going to leave us, it's going to cancel and leave us with 2x is equal to 10. Now we have 2 times x, so that's multiplication, so we're going to do the inverse, which is division. 2 over 2 is 1. X is equal to 5. So let's sub that into the original equation and see if that works. So 2 minus 3 times 5 plus 6 plus 5 times 5 is equal to 18. Let's see if that works. So 2, and that's 3 times 5, that's going to be a negative 15 because this is negative, plus 6, and then 5 and a positive 5, that's going to be plus 25, is equal to 18. All right, so in my mind, I see that I have 4 terms with their signs, right? This is a positive. So I'm going to combine this positive and this positive because I can do 6 and 2 and get 8 in my head pretty quickly. So that's a positive 8. And then I'm going to take this negative and this positive because they are both, they both end in 5. It makes it easy for me to subtract that in my head. And this is the bigger number. So I'm going to say 25 minus 15. That leaves 10. So plus 10. 8 plus 10 does equal 18. So it tells me my solution of 5 is correct. So let's look at example 6. In example 6, we have a lot of things going on. We have some parentheses, and we have some multiplication, we have some negative numbers. So let's just start with the first parenthesis. So I'm going to multiply 2 times y and get 2y. 2 times negative 4 is a negative 8. All right, now I have a negative 5 times y, so it's negative 5y, and a negative 5 times positive 3. Negative and positive are different signs, so this is going to be a negative 15, is equal to negative 35. Sometimes you might need to write that a little bit better so it's clear that it's a negative number. Little things like that can make all the difference. Just the way you write it down on your paper can help you to solve it better if you make sure that you write neat and clear when you do your problems. So now let's combine like terms. So I see a negative 8 and a negative 15 for my constants. I see a positive 2y and a negative 5y. Combining these two negatives are the same sign, so that's going to be a negative, and that's going to be negative 23. And this is a positive and a negative, and the 5 is bigger, so it's going to be a negative 3y is equal to negative 35. To get rid of this negative 23, I'm going to add 23 to both sides, which would make this cancel. So I have negative 3y is equal to, that's going to be negative 12. Because the bigger number is negative, so you subtract when the signs are different. So this is going to be a negative 12. And now I have a negative 3 times y. So I want to divide by a negative 3 on both sides. A negative and negative make a positive 1. So 1y is equal to negative 12 divided by negative 3. The signs are different. The signs are the same. So it's going to be a positive answer. So now I just have to look at the numbers. 12 divided by 3 is 4. So y is equal to 4. So now I can put that back into my original problem and see if that's correct. So 2 times 4 minus 4 minus 5 times 4 plus 3 is equal to negative 35. So 4 minus 4 is 0, right? 2 times 0 is 0. So I can just ignore this entire thing, or I could just write 0 to make myself feel better. Now 4 plus 3, that's 7. Negative 5 times positive 7 is a negative 35. 0 minus 35 is negative 35. So y equals 4 is correct. Let's do another. Now in example 7, we're not actually solving for a value, but what I want to illustrate is that we can use the same process in order to solve for a given variable if we need to. We can swap it around until we find what we need to find. So we're going to do the inverse operations here. And this is our DIRT formula. Our distance is equal to rate times time. But we want to find out what the relationship to rate is. We want to find out what R is equal to. So we are going to solve to get R all by itself. So if I want to get R by itself, I'm going to divide, it's R times T. I'm going to divide by T. But if I do it on this side, I have to do it on this side because it's an equation. So T divided by T is 1, whatever that is. So what I have left is 1R is equal to distance divided by time. And that is the value of R. In our final example problem, we see that not only can we apply inverse operations to equations, but we can apply them to geometry as well. So in this problem, it says find the width of a rectangle if the perimeter is 98 inches and the length is 36 inches. So what we have to do is go back to the formula of a perimeter. So perimeter is equal to length times width, right? So let's put in the information we're given. 98 is the perimeter, and the length is 36. And then W is going to stand for the width that we don't know. We're told to find the width. So that is our unknown variable. So now that we have 36 times W, we're going to divide both sides by 36. Because whatever you do to one side, you do to the other side. And 98 divided by 36 is going to be, I'm sorry, I've messed up already. That is not the formula for perimeter. The formula for perimeter is 2 times the length plus 2 times the width. I'm sorry, I was thinking about area when I wrote that. Perimeter is what we have. Perimeter is 2 times the length plus 2 times the width. So now let's put perimeter in. It's 98. And the length is 36. So 2 times 36 plus 2 times the width. So we know what 2 times 36 would be. That'd be 98 is equal to 72 plus 2 times W. So I can subtract 72 from both sides. This would cancel, and that would leave 24. Because 98 minus 72 is 24, and 98 is the larger number. Is it 24? No, I'm sorry. I did the math wrong. It's 26. 8 minus 2 is 6, not 4. For some reason in my head, I divided. I don't know why. So 26 is equal to what's left, which is 2W. So now we have 2 times W, so we divide both sides by 2. 26 divided by 2 is 13. 2 divided by 2 is 1W, which we don't write. We just have the W. So 13 is the width. So we can double check that by putting it back into our original equation. We're going to start here. 98 is equal to 2 times 36 is 72 plus 2 times 13. So 98 is equal to 72 plus 26, and we know that those two added together does indeed make 98. So the width is 13 inches. So first of all, make sure you have the right formula when you get started. Then you can solve by undoing the formula, so to speak, by putting in the information that you have. So even if you have something like area or perimeter or volume, and you have a couple of the dimensions that you need to get there, or one of the dimensions you need to get there, you can undo a final answer by putting it equal to the formula and subbing in the values that you have that go in that formula. Then just like we did here, it allowed us to solve for the width. Just make sure, like I said, you have the right formula to start with. Actually, length times width is area. So if you had a square and it was 4 by 4, the area that it covers is like a sheet of paper. You would have 16 square inches because the length is 4 and the width is 4, and that would be 4 times 4, which would be 16. So I got that mixed up because they both have length and width in them. And it was just a brain. See, I'm getting older. My brain doesn't work as well as it used to. I need to do some more math problems. So again, perimeter is 2 times the length plus 2 times the width. We undid it and solved for width. And that is all we have for lesson 1.6. We have one more lesson in chapter 1, which is 1.7, and we'll see you in that.